If you can see what's on this projector, you're doing better than I am. Let me make it bigger. So just, what's the next time we meet? The final exam, right? So there's no class Thursday, am I right?
There is.
There is?
There's no class on Friday.
Wait, but there's class on Thursday?
Exams start on Friday.
Yeah, exams on Friday and then they go up till next Thursday.
Oh, see, I was thinking Thursday was reading day. If I'm wrong about that, that's... Oh, yep, you're right. So we have another review Thursday. This Thursday, yep. The final... Well, I'm glad you told me that. It would have been so embarrassing if I didn't come to school Thursday. That would have been bad. Let's see here. So,
No class on Friday, Monday, Tuesday, Wednesday,
so we don't have a reading day here then. There's no
after all your exams.
there's no day between classes and the finals, right? It's just class Thursday.
Days, yep, these 4 days and Friday's the last your exams.
Okay. Well, thank you. I had forgotten that. Obviously, I knew it when I wrote the course planner, but it's so thank you for that, Brianna. So we, of course, have a class time from 11 a.m. This starts at 11 a.m., right? So that's us here, which means our finals Wednesday, December 8th, from 11 to 1. And it should be in this room, all right? So any questions about anything else? Is it going to take 2 hours? That depends on how much you know. What about what? What about Monday? What about Monday? At 8 a.m. See, the scheduled at is what's important. Scheduled at 8, scheduled at 12:20. So we're scheduled at 11 a.m. on so yeah, we're on Wednesday. Because we start at 11, our finals here, Wednesday, December 8th. Pretty good. Jalen? Here you. Let's see here. Caden?
You got a haircut, didn't you?
I did. That's true. You got me. Okay, so let's look at the solution to test 3. For today, that's what we'll do. All right. What? Sorry, I was trying to open it with the Adobe. I'll eventually figure it out here. I got to get to downloads. No, this is an in-class survey. Man, all right, fine. We'll just use this. You guys can see this, right? Ah. There we go. Come on. It won't let you zoom in. That is aggravating. All right, finally. All right, so let's work through this here together. Go away. All right, so problem 1. So some of you had like infinity before the number and minus infinity after somehow. So that's easy to fix for the final, right? Some of you had something that looked like this, but you had like, I think 3 here or 2, or I saw a lot of different numbers here other than 7/2. You need to think through what we should put there, right? Whatever we put there is the thing that cannot be in the domain because we're excluding that point. So here, the question is, when is 2x minus 7 equal to 0, right? So that happens when 2x is equal to 7, which dividing by 2 is 7/2. So that's the number we have to exclude. But I did give you partial credit if you had an understanding. It looked something like this, but you got the wrong number in here. I did give significant partial credit for that. A lot of people need to work on problem 2. You need to, try to understand for yourself which one of the rules you're not implementing. I don't know. I don't have the gift of discerning which step you're doing wrong. I just know that you got the wrong numbers. Some of you didn't. But so this thing here is we've got square root, and so the square root of product is product of square roots, but then that's to the 1/2, that's to the 1/2. So 6 over 2 is 3, 3 over 2 is, 3/2, and so from that you can see A is 3 and B is 3/2. The next one here, so I saw some people get part A completely right, and they were just blanked on part B, which I thought was unusual. But the key for part B here is that the 1 over x gives you an x to the minus 1. All right, the 1 over y to the minus 3, that translates into multiplication by y to the 3rd power. And so once you have it like that, you just add exponents, y squared times y cubed is y to the 5th. X to the minus 7 times x to the minus 1 is x to the minus 8. And then from that, you can read, I put them back in the orders to match the pattern. Looking at this to this, you can see A is equal to minus 8 and B is equal to 5. So this is something students struggle with, and it's worth your time if you're getting those wrong to stop and spend significant time on this problem, because it will be an issue in your next math class. You guys take another math class, right? Calculus? I think most of you will take another math class. Problem 3, man, a lot of people got this problem right. So I was pleased to see that. To get it, you just multiply by x over x, right? Problem 4. So this is what I wanted you to do, but I admit the instructions simplify are quite vague. So I tried to be generous in the sense that I didn't take points off if you did some non-trivial step, which I thought was a simplification, right? However, if you also wrote things which were incorrect, I took points off. So I don't know. I need to find a way to make this problem less fluid in terms of the answers, because there's about 10 answers that I would take here as correct. All right? Anyway, so the way I did it was just to break the sum in the numerator up into the sum of the fractions, right, like that. And then like x over x cubed is 1 over x squared. X cubed over x cubed just cancels. X to the 5th over x cubed is x squared, right, because 5 minus 3 is 2. And then 8 over 4 is 2. 12 over 4 is 3. 48 over 4 is 12, but there's a minus there. A lot of people did something correct here and didn't lose points. Others, not so much. I said rewrite the expression as a single fraction in the next one. So this one is a little bit less forgiving in terms of what is allowed for answers. But basically the point here is to make a common denominator. This is x plus 3 squared, and this is, of course, x plus 3. So we just have to multiply the first fraction by x plus 3 over x plus 3 to make them have a common denominator. And that gives you this, which is x plus 2 over x plus 3 squared. I had 2 or 3 people leave their answer like this, which I thought was kind of funny because, like, I believe that you guys know that 3 minus 1 is 2. But maybe you also know me well enough to know I wouldn't take a point off. I don't know. I'm not sure what it is. Now, one of you, I think just one of you cross multiplied. You did like the first fraction times x squared but plus 6x plus 9, and the second fraction times x plus 3, and then the denominator was a cubic, right? I would caution you, if you take that approach, that if I add the word simplify to this problem, if it reappears on the final with an added word simplify, then what you did won't be counted correct anymore, because if you just cross multiplied here, you'd have some simplification to do before you got to like this answer. So cross multiplying is okay, but you should be looking for easier, well, let's see here. It's a good practice to try to look for the least common multiple of the denominators. But anyway, you can see I didn't think that was too big an issue because I didn't take a point off your paper, whoever you were. I don't remember who you were because I don't look at names when I'm grading. I just grade problem by problem, you know. So. Problem 6. So here I actually used the cross multiply, basically. So I did x squared over here and x minus 2 over there, which gave me this. And then, so I did give this full credit because I didn't ask to simplify in this problem. But if I had asked to simplify, I would have wanted you to do this, right? So this is the best answer for this problem, but this is a perfectly fine answer. Even this answer up here is still perfectly, I mean, it's a correct answer because it is, after all, writing that difference of fractions as a single fraction, so you followed the instructions if you did that. There's a little bit more going on in problem 7, because problem 7 is a little bit more tied to the problem of factoring, which everyone needs to work on in here. Like factoring is a big deal. Probably 30% of your final is factoring, something like that. More than likely. Factoring is a big deal. So x squared minus 9, x plus 3 times x minus 3. I can pull the 4 out, see that? And then I've got an x cubed plus 6x, right? So there's an x I can also factor out of that. So I've got x times x squared plus 6, but I've also got an x squared plus 6 downstairs. So these reduce, they cancel out. The x minus 3 canceled in the step above there. And you're ending with 4x times x plus 3. Of course, you could also multiply this out. I also took 4x squared plus 12x as an answer here. That's fine. So I have a few additional variants of the answer written on my solution now. I'm going to re-scan it and post it again with the additional answers because I've improved the solution a little bit after I graded your test yesterday. Well, today, technically. But, so you can, that won't make too much of a difference in your studying, but I do intend to repost the solution to test 3 with some additional forms of the answer. So, guys, here, I never, ever in this class use this kind of language. Like, this is not something I write. If I was to write that, I would write 3 plus 1/2 for one thing, right? This is very different than 3 to the 1/2. So this is an exponent. It's not an improper fraction. It's not a mixed number, which is what I think 2/3 of you interpreted this as. So notice that it's up, you know. Anyway, so now you know. And so when we laws of exponents, we get 3/4 minus 5/8. Yes, many of you have the same wrong answer because you interpreted this as 7 3/4 and 7 and, I can't read it from here, 5/8. And then you converted to fractions, and this is not the question. This is separate. That might be a question for like whatever class is before this, but it's not a question for this class. So anyway. Sorry for the confusion, but there was no problem in the homework that was like convert mixed fractions to a fraction, right? Problem 9. We have simplify the cube root of minus 8x to the 12th. So The cube root of the product is product of the cube roots. So I change this to the cube root of minus 8 times the cube root of x to the 12th, which the cube root of minus 8 is minus 2. And x to the 12th to the 1/3 is x to the 4th, so minus 2x to the 4th is the answer here. Many of you had this, so that was encouraging to me. Problem 10, very similar. And, yep.
Oh, for the final, do we get like a study guide, or do we have to make it ourselves? Like how we've been doing.
What is the nature of this? I don't understand the question.
Like, you know how like we've had to make our own sheets,
Mm-hmm.
study on our own.
Yes.
We get a guide to help us.
No, I do not have a study guide for the final. But I will tell you that the 3 tests that you've already had are a pretty good indication of what the final is. So I take the problems from those 3 tests, give or take, change numbers and formulas and junk, and try to make it a 2-hour test that adequately represents all 3 of the previous tests. I have to do that because, I replace your earlier test grade with the final exam grade if helpful, right? So that's only fair if the test is actually comprehensive. And so
Do we get one page for the final?
I usually allow 3 for the final. Yeah. So, but I don't know. I mean, how many questions are on it? Oh, I don't know. About 2 hours worth of questions. By and large, you guys did this one pretty good. I think the people who did it wrong, so the most common mistake in here is instead of multiplying by 3 minus root 2 over 3 minus root 2, you've multiplied by 3 plus root 2 over 3 plus root 2. You got to remember to change the sign. That's where the magic happens. When you change the sign, you end up canceling the radicals in the denominator, which is what you want here. All right, so that's an easy thing to fix. Like I could see that some of you were like not quite done studying because you put a plus here instead of a minus. But if you did that, that's good. It's just a little bit better. You need to just continue instead of putting pluses, put minuses here and work it out. And then other people lost something up. So this is wrong right now. I haven't had a chance to read the next problem. Check this out. So I've done nothing but math my entire adult life, but I still make this mistake, right? Check this out. So 2 plus 4 is 8. No, it's not right, right? I multiplied them. I don't know why I did that, but fall of man, I guess. But so the square root of 3 squared is 3. 8 plus 3 is 11, so that's why I get 11 plus. That should be 6 root 3. I'll put the corrected solution up here sometime later today. But anyway, that's supposed to be 11 plus 6 root 3 over, what's that number in the denominator? 13? Yeah. There you go. You guys do better at equations than expressions. I feel like equations are more of your happy place, yeah? So this one was 5/13. If you didn't get 5/13, but you got to here, I tried to give you partial credit, The next one, some people, so here's the error I saw with one person's question number 14. When you made a common denominator here by basically multiplying this one by, basically what one person did was multiply this by 10 and then multiply it by 15, but they didn't multiply the right-hand side by 10 and 15. If you multiply this whole equation by 10 times 15, you get 15x minus 10x equals 3 times 10 times 15, which is 450, which then gives you, let's see here. That would give you 5x equals 450. But anyway, let me focus back here. So I made a common denominator of 30, and then that gave me x over 30 is equal to 3. And then I multiplied 30 on the other side, I get x equals to 90. What is one of the things I could have been doing here to be extra sure I was right? I could have been plugging these numbers back into the equation, seeing if it worked, right? Missed opportunity for me. This one here, multiply both sides to the equation by 4 plus 3x. That gets us to 2 times 4 plus 3x, which is 8 plus 6x. And then I just isolate the x, isolate the number. That gives me 3 plus 3x. 3 equals to 3x. Divide by 3, x equal to 1. This one here, I think a lot of people got right. You just square it. When you square it, the square roots go away. And that leaves you 3x minus 11 equals to 5 minus x. Again, we're back to like week 1 in the course. So we put all the x's on one side, put all the numbers on the other, divide by 4. There you have it. There were more problems from more people on the next page, the final page of the test. Here you guys, there's a number of you who need to work more on this. The critical thing you need to work on is it's a deeper problem, which is that if we have a plus b and we square it, right? This gives us a plus b times a plus b, which gives us a squared plus ab plus ba plus b squared. Or you could rewrite that as a squared plus 2ab plus b squared. A lot of you are ignoring the 2ab term in the middle when you square it. Okay, like that's what I saw a lot of people do is for this one, well, first of all, they just squared the original equation, and then they just got to like x squared plus 2x minus 3. But there's something in the middle that would have been minus 2x times the square root. So like, if you've got something plus a square root, you're going to get 3 terms. You get the term in the middle of the square root, you get 2 terms on each side. So what I did was to isolate the radical. So I did that by subtracting 3 to one side and adding the radical to the other. And so I square both sides, which gives me a quadratic equation, which then we can factor. And I find 2 solutions, 6 or 2, but the 2 is extraneous, as you find out from plugging in and seeing if it works. I think about 5 people in here got this right, maybe 10. So this one here, again, here you can better see the mistake. A lot of you squared both sides, right? You thought you squared both sides, but what you did, the square root of 2x plus 8 squared, great, fine. But over here, this middle term was missing for you. See, because when you're thinking about a plus b squared, you're basically just saying it's a squared plus b squared. But it's not just that. It's missing the middle term, the 2ab, which here is this 2 times 1 times the square root of x plus 5. So this is that you have to deal with it. It's there, all right? And so since it's there, you isolate it, isolate the radical, and then you can square both sides again. And again, we get to a quadratic equation, which we can solve, right? Like so. And it turns out to actually be kind of a nice quadratic equation. We just get plus or minus 4 as the solutions. And then again, you have to go back in and check which one works. Only 4 works. The other one's extraneous as it happens here. And that's it. So Thursday, we have all of Thursday to talk about test 1 and test 2. Anything that is still mysterious to you in the course, like we bring all those questions Thursday, right? We have the whole time just to review for the final, all right? And if I can find one, I'll show you a final from a previous semester. I think I have one sitting around somewhere. So let's see here. I was going to say, so I need a volunteer to collect the course surveys. Who's a volunteer? You got it? Okay, so once everybody's